Hello, and welcome to INSY 2203 Networking Fundamentals. This is Instructor Davis. In this session, we will review switch configuration. As mentioned on the first slide, we will be reviewing switch configuration in this session. Specifically, we will take a look at virtual local area networks, switch configuration techniques, spanning tree protocol, network management, power over Ethernet, and switch security. A switch can be configured as a VLAN, which is a virtual local area network, where a group of host computers and servers are configured as if they are in the same local area network, even if they reside across routers in separate local area networks. The advantage of using virtual local area networks is the network administrator can group computers and servers in the same virtual local area network based on the organizational group. Example, sales, engineering, even if they are not on the same physical segment or even the same building. There are three types of VLANs. That's port-based, tag-based, and protocol-based. The port-based VLAN is one where the host computers connected to specific ports on a switch are assigned to a specific VLAN. For example, assume the computers connected to switch ports 2, 3, and 4 are assigned to the sales VLAN, while the computers connected to switch ports 6, 7, and 8 are assigned to the engineering VLAN. The switch will be configured as a port-based VLAN so that the groups of ports 2, 3, 4 are assigned to the sales VLAN, while ports 6, 7, and 8 belong to the engineering VLAN. The devices assigned to the same VLAN will share broadcasts for that local area network. However, computers that are connected to ports not assigned to the VLAN will not share the broadcast. In tag-based VLANs, a tag is added to the Ethernet frames. This tag contains the VLAN ID that is used to identify that a frame belongs to a specific VLAN. The addition of the VLAN ID is based on the 802.1q specification. An advantage of an 802.1q VLAN is that it helps to contain broadcast and multicast data traffic that helps to minimize data congestion and improve throughput. This specification also provides guidelines for a switch port to belong to more than one VLAN. Additionally, the tag-based VLANs can help provide better security by logically isolating and grouping users. In a protocol-based VLAN, the data traffic is connected to a specific ports based on the type of protocol being used. The packet is dropped when it enters the switch if the protocol doesn't match any of the VLANs. For example, an IP network could be set up for the engineering VLAN on ports 6, 7, and 8, and an IPX network for the sales VLAN on ports 2, 3, and 4. The advantage of this is that the data traffic for the two networks is separated. There are two approaches for assigning VLAN membership. A static VLAN is basically a port-based VLAN. The assignments are created when ports are assigned to a specific VLAN. In a dynamic VLAN, ports are assigned to a VLAN based on either the computer's MAC address or the username of the client logged into the computer. This means that the system has been previously configured with the VLAN assignments for the computer or the username. The advantage of this is the username and/or the computer can move to a different location, but VLAN membership will be retained. Configuring a switch requires that the privilege mode be entered on the switch. The privileged exec mode, also called the enable mode, allows full access for configuring the switch ports and establishing a VLAN. Layer 3 access to the switch is set by using the following command. Note that the IP address is being set for VLAN 1. The interface for the switch is also enabled at the same port using the no shutdown command as shown. A link management protocol that prevents looping and also controls data flow over possible redundant data paths. Switches that are participating in the spanning tree protocol exchange information with other switches in the form of bridge protocol data units. Switches use the BPDUs for election of a root switch for the spanning tree network topology and removing redundant data paths. Switches assume that they are the root switch until the BPDUs are exchanged and a root switch is elected. The root switch elected is the switch with the lowest MAC address. Part of the BPDU packet is shown below. In this case, a switch with the MAC address 0, 03019-4A6940 is issuing the data packet at the start of the bidding process to see which switch will be elected as the root switch. BPDU config BID equals 0030194A6940. PID equals 0 times 801X, or I'm sorry, 1B. The config indicates that this is a configuration BPDU and is used by the switches to elect the root switch. There are two other types of packets that can come from the switch. These are TCN and TCA. Topology change notification, TCN, which is used to indicate that there has been a change in the switch network topology. Topology change notification acknowledgement, TCA. This is an acknowledgement from another switch that the TCN has been received. There are 5 spanning tree protocol states: blocking state, listening state, learning state, forwarding state, and disabled. Blocking state. In this state, the switch is not sending data out of the ports. However, the switch is receiving and monitoring BPDUs. This state is used to prevent any possible switching loops. Listening state. BPDUs are being processed. Learning state. The switch is learning source MAC addresses from the received data packets and will add the addresses to the MAC address table. Forwarding state. The switch is now sending and receiving data packets. The BPDUs are still to be monitored for any possible change in the switch network. Disabled. This is a setting available for the network administrator to manually disable the port. This is not part of the spanning tree protocol, but rather a function available on the switch. A fundamental network management tool is the SNMP, the Simple Network Management Protocol. SNMP, developed in 1988, is widely supported in most modern network hardware. SNMP is a connectionless protocol using the UDP, the User Datagram Protocol, for the transmission of data to and from UDP port 161. Obtaining the SNMP data requires that SNMP be configured on the switch or router. The first step for configuring SNMP on a Cisco router is to enter the router's configuration mode using the CONFT command. From the switch or router's config pound, prompt enter the command SNMP community string permissions. The community string can be any word. The permissions field is used without establishing if the user can read only, write only, or both. SNMP uses a management information base, which is a collection of standard objects that are used to obtain configuration parameters and performance data on a networking device such as a switch or a router. For example, the MIB, if described, returns a description of the router's interfaces. An example next is shown. An SNMP software tool was used to collect the interface description information. The IP address of the router is 10.10.10.1, and a GET request if description was sent to port 161, the UDP port for SNMP. The descriptions of the interfaces were returned as shown. The illustrations shows another example of using SNMP to obtain interface information about a router. The SNMP manager was configured with the host IP address of 10.10.10.1, a set value, port number of 161, and the 10-character community string of a matrix shown as. The MIB was sent to the router and a status for each of the interfaces was provided. The data displayed shows the speed settings for the router's interfaces. One of the challenges the network administrator faces as the campus network grows is making sure that the electrical power is available for the networking devices. It is not always practical or affordable to run electric power every place a networking device is needed. This challenge is met with Power over Ethernet. This provides a better network cabling, Cat5 or better, to the networking device. The benefits of PoE include: it is not necessary to run external power to all networking devices. You can run power and data over one cable, and monitoring of power management via SNMP networking devices can be moved easily. The power provided by PoE is defined by IEEE 802.3 AF requires 15.4 watts per port to Ethernet devices and 48-volt systems. There are two pieces of networking hardware defined in PoE. These are the power device and the power sourcing equipment. There are three main functions provided by the PSE, which are capability of detecting a PD, supplying power to that PD, and power supply monitoring. There are two types of power sourcing equipment. These are the endpoint PSE and the midspan PSE. An example of an endpoint PSE is a source port over an Ethernet switch that connects via a cable to a PD. A midspan or midpoint PSE is used to provide power to a PD when a powered Ethernet port is not available. This setup requires the use of a power injector and typically uses pairs 4 through 5, 7 and 8, and this does not support 1000 base T connections. The power to the PD can be delivered in two ways: over the active data pairs, which are 1, 2, 3, and 6, or via pairs 4, 5, 7, and 8. This is shown on figure 913, A and B. Both types of power delivery can be used for 10 base T, 100 base T, and 1000 base T. The most common way of power delivery is over pairs 1 through 2 and 3 through 6 as shown in the figure. The PD is the actual device receiving power such as wireless access points and an IP phone. There are four classes of PD devices. Class 0, which is 0.44 to 12.995 watts. Class 1, which is 0.44 to 384 watts. Class 2, which is 3.84 to 6.49 watts. And Class 3, which is 6.49 to 12.95 watts. PD devices are discovered by the PSE by sending discovery signals on active and inactive Ethernet ports. The discovery process is called resistive power discovery. It is basically looking for devices that support PoE. Valid PDs will have a 25 ohm resistor connected between the transmit and receive pairs. Before full power is delivered to the PD, two low voltage discovery signals are sent out to verify that a compatible PoE device is attached. The second of the two signals is a slightly higher voltage than the first, but neither is large enough to damage an incompatible device. If the PSE detects a compatible PD, then the full 48 volts is applied to all ports that have compatible PDs connected. A new version of Power over Ethernet called PoE Plus, based on the IEEE 802.3 AT standard, is now available. PoE Plus provides support to both 802.3 AF and 802.3 AT PDs. Support for midspan PSEs for 1000 base T. Supports a minimum of 30 watts of power for the PD, support for the 10G base T, and will operate with Cat5 and higher cabling. Switches are commonly used in the access layer of the network hierarchy. The access layer connects users who share the common network resources and bandwidth. Directly interfacing with users can create security challenges, as there is no telling what will be connecting to the switch access ports. The more control or policy that can be enforced at the switch port level, the better off the network will be. A very fundamental security rule and best practice is to disable any unused ports. A very useful command to use when applying the same command to a group of switch port is the range command. 802.1x, sometimes referred to as .1x, is a more advanced technique that can be used to authenticate users to gain access to wired and wireless devices. 802.1x is an IEEE standard across control and authentication protocol that prevents unauthorized devices from connecting to a network through publicly accessible ports unless they are properly authenticated. With 802.1x, a switch is in communication with an authentication server, and an authentication server authenticates each device connected to a switch port before the services are made available to the device. By default, VLAN 1 is always enabled on every switch, even when no other VLANs are configured. Switches automatically carry the traffic on VLAN 1, so VLAN 1 becomes a default native VLAN. It is recommended as a best practice to avoid using VLAN 1, but rather to create different VLANs for different purposes and to change the native VLAN to one of those new VLANs. Switch port security or port security can be configured to restrict the port's ingress traffic by limiting the MAC addresses that are allowed to send traffic into the port. The command to enable port security is a switch port security. This command has to be issued at the interface level. You can configure a switch port to restrict access by setting a maximum number of MAC addresses, or you can configure it to only allow known MAC addresses to pass traffic. With the sticky option, the configured MAC address appears in the running configuration of the switch and saves in the startup configuration. This way, when the switch reboots and the configured MAC address remains part of the configuration. Also, make sure to review the reading for this week for additional switch security techniques. In this session, we reviewed switch configuration, including VLAN switch configuration techniques, spanning tree protocol, network management, power over Ethernet, and switch security. As always, if you have any questions on this session or any others, feel free to post in the Q&A forum or send me a message via course messaging or by email, and I'll be sure to get back to you. Thanks for watching, and have a great day.